This is Euclid Book 7, proposition number 28, and I'm going to go ahead and show you the diagram. If you need to, pause the video. Okay. Now let's go through this, shall we? If two numbers be prime to one another, the sum will also be prime to each of them. And if the sum of two numbers be prime to any one of them, the original numbers will also be prime to one another. So let two numbers A, B, and B, C. Well, as you can see here, we have a line AB and a line BC. See that? And they'll be prime to one another. Okay? Now, we're going to say that line AB is 8, line BC is 5. Well, 8 is not a prime number. 5 is, 8 is not. Okay? But there is no number that will both divide 8 and 5. Okay? That's why they're prime to one another. Okay? Now we're going to add those numbers. Well, 8 and 5 makes 13, which happens to be another prime number. Okay? I say that the sum AC is also prime to each of the numbers A, B, and BC. Okay? So what we're going to say is that AC is prime to AB, which 13 is prime to 8, and 13 is prime to 5. Okay? That's what we're going to say. For if AC and AB are not prime to one another, okay, some number will measure AC and AB. And we're going to say that the number that measures them is going to be D. We're going to assume that the number 2 is going to measure both 13 and 8. Okay? Now I know it doesn't really measure 13 and 8, but we're going to suppose it does. Since then D measures AC and AB, therefore it will also measure the remainder BC. Well, obviously D, which is 2, will not measure 5, which is BC. But it also measures AB. Okay? Well, 2 does measure 8. Therefore, D measures AB and BC, which are prime to one another, which is impossible, which is by Euclid Book 7, definition number 12. Therefore, no number will measure the numbers AC and AB. Okay? We got that. Therefore, AC and AB are prime to one another, which, of course, 13 is prime to 8. For the same reason, AC and CB are also prime to one another. Okay, AC is 13, CB is 5. Well, actually BC, which you can read it BC or CB, it doesn't matter either way, it's still going to be 5. So 13, of course, is prime to 5. Therefore, AC is prime to each of the numbers A, B, and BC. Well, 13 is definitely prime to 8, and 13 is definitely prime to 5. Again, let AC and AB be prime to one another. Well, AC is 13, so that automatically is prime. AB is 8, and 13 is prime to 8. Okay? I say that AB and BC are also prime to one another. Alright. So, 8 is prime to 5. For if not, some number will measure both A, B, and BC. And we're going to presume that D can actually measure 8 and 5. We know that it can't, but we're going to presume it can. Now, since D measures each of the numbers A, B, and BC, it will also measure the whole of AC. Well, D is obviously not going to measure 13, and it's not going to measure 5, so there you go. But it also measures AB, which is 8, which it does. Therefore, D measures AC and AB, which are prime to one another, which of course is impossible, by Euclid Book 7, definition number 12. Therefore, no number will measure the numbers AB and BC. Therefore, AB and BC are prime to one another. And that's the proof. Alright, I will tell you more in a future video. Stay tuned.